Today we're going to look at integration by parts. Okay, so make sure you have your notes printed out, and I gave you at the top the formula right here. Integral of u dv equals uv minus integral of v du. You want to make sure you memorize this. We'll do it a whole bunch right now, and it'll get stuck in your head. It comes from the product rule, and you can see in your book, how to get it, but I kind of showed you right there. What you also want to memorize, all right, look at your steps for integration by parts. Your first step is to pick U, and you go in this order, L-I-A-T-E. You want to memorize that, L-I-A-T-E. L stands for natural logs, I is inverse trig, A is algebra, T is trig, E are exponentials. And so that's not going to make a ton of sense to you right now, but you're going to, when we start these examples, I'm hoping to make that clear. Okay. Step 2, let dv be what's left over. Step 3, draw me a box, fill in the parts. Or we're going to do the tabular method. We'll do that when it comes to that example D. Plug into your formula, simplify and integrate. All right, so again, I want you to memorize L-I-A-T-E. That's the order that we pick U in. So we use integration by parts when we're trying to integrate the product of two functions. All right, so let's look at this first one. All right, integral of x squared times the natural log of 7x. All right, so you can see you have two functions. You've got x squared and you've got the natural log of 7x. So you want to decide what those two, what kinds they are. What am I going to classify them? And that's where that L-I-A-T-E comes in. So anything like x squared, that's going to be an algebra. Okay? And then obviously that natural log 7x is an L for those natural logs. Right. So when you're going to use integration by parts, okay, you're going to pick U. Okay, so we're going to go ahead and draw our box. All right. You're going to do U. That's an equal sign. U. Let me just, let me just start that better. Okay. You're going to draw a box. Okay. You're going to do U equals du equals v equals dv. Alright, so your first step is to pick U. Okay, so you go in the order L-I-A-T-E, which means you pick, if you have L's, you pick those first as U. Well, I do in this one, so that's natural log of 7x. Okay, and then whatever else is left over, whatever we didn't use, if you take out that, alright, that becomes dv. Okay. Alright, now, so if I go back, alright, we did this, we picked U, and we let dv be whatever's left over. We went ahead and drew our box, okay, but now we need to fill in the parts, okay, and then we're going to plug into that formula. So, if U is natural log 7x, I need to get du. That's just the derivative. Remember to take the derivative of a log, we put whatever's behind the ln on the bottom and the derivative of the bottom on the top, so those are going to cancel, so you're going to get 1 over x. Alright, now you're supposed to put a dx with that right there if that's your variable x. A lot of times I forget that, so forgive me if I do. Alright, and then we got to figure out v. So when you've got u, you take the derivative to get du. When you've got dv, you've got to integrate it to get back up to v. So I need to integrate x squared dx. So that's when you just do the power rule, add 1 to it, divide by the new power. Okay, you don't put the plus c or anything right there. Okay, so once you get your box filled in, you're good to go. You've got to memorize your formula. The integral of this is going to be uv minus the integral of v du. So we're going to plug in for these parts. So u, natural log 7x, alright, v, 1/3 x cubed, minus the integral of v, 1/3 x cubed du, 1 over x dx. Okay, so you're going to simplify this formula. Alright, well, when you get ready to multiply that uv in the front, you remember that natural log 7x, that 7x is locked in at 7x. You can't multiply that together, so I'm just going to write it 1/3 x cubed natural log 7x. Alright, but I can do some simplifying here. Alright, I'm going to take that 1/3 and pull it on the outside. Okay, now when you get ready to multiply this x cubed times this 1 over x, one of the x's will cancel, and you've just got x squared dx. Okay, so you've got to now simplify that. You've got to do that integral, but we've already done it. We already know. We had it right here. We know what to integrate it as, that it's going to end up being that. Okay, so we've got 1/3 x cubed times the natural log of 7x minus 1/3, all right, times another 1/3 x cubed. And then we put our plus c on there. So multiplying that together, and I get, all right, 1/3 x cubed natural log 7x minus 1/9 x cubed plus c. Okay, there you go. All right, let's do another one. Okay, so we've got the integral of x times secant squared dx. All right, so let's look at what we got. We got an x, we know that's an algebra, and then we got a secant squared x, which that's going to be a trig. All right. So I kind of like to do steps 1, 2, and 3 together. All right, let's see, separate that. So let me draw my box and start picking my pieces. Alright, so you're going to do u and du. You're going to do v and dv. Alright, so we got an x and we got a secant squared. We got an a and we got a t. We got to go in the order L-I-A-T-E. So don't have any L's, don't have any I's, but I do have an A. Okay, so I'm going to let u be the algebra, which means whatever's left over, which is secant squared x dx, becomes dv. Okay. Alright, fill in your box. If u is x, then du is just 1 dx. Alright, and if dv is secant squared x dx, whose derivative is secant squared? If you're going to integrate it, it's tangent. Okay, so not bad, and so you're going to have this memorized. This is equal to uv minus the integral of v du. So let's plug in. So it's u v minus the integral of v du. Alright, so nothing I can do here. I'm just going to write x times tangent x, alright, minus the integral of tangent x dx. This is something you are supposed to have memorized already. Okay, but if you have forgotten it, alright, let's look at it. You know you can call that tangent is sine over cosine. And you're going to let u be the bottom. Alright, what is the derivative of cosine? It is negative sine. So I am missing a negative sign, so if I throw one in, then I'll cancel it. So that's going to be x tangent x plus, alright, that's going to end up being 1 over u du, so that's going to be natural log of the absolute value of u. Okay. Alright, let's do some more. Alright, integral of 3x e to the 4x. Let's look at what we got. So we've got 3x, which is going to be an algebra, and e to the 4x, which is an exponential. Okay. Alright, so got a little bit more room here on this one. Alright, well, I'm going to wait, let you pick it, sorry. Let's just fill in this part. Alright, so u du v dv. Sorry, it's getting ahead of myself. Alright, so we go in the order L-I-A-T-E, no logs, no inverse trigs. I do have algebra, so we're going to let u be 3x. Alright, dv is going to be e to the 4x dx. Okay, so filling it in, u is 3x, du is 3 dx. Alright, now we got to integrate this, e to the 4x. We're going to do this one like this, and then I'm going to show you something to memorize a little bit later. So this one, I would let u be the exponent on e. We've done this. Then du would be 4dx. So I need to multiply into 4, cancel it with a 1/4. So I get 1/4 integral e to the u du, so it's just 1/4 e to the u. Okay, if it's just an x to the first power as your exponent on the e, when you integrate it, it's just going to be the reciprocal of the coefficient of the x, and we'll talk about that with the tabular method in just a second. So you don't want to have to do that u substitution every time if you have a simpler one like this. Alright, so I'm going to move it down here. We've got uv minus the integral of v du. So uv minus the integral of v du. Okay, so I'm going to multiply in the front. I'm going to multiply that 3x times that 1/4. I'm going to get 3/4 x e to the 4x minus, I'm going to pull out that 1/4 times that 3. And if I pull that 1/4, that 3/4 out in front of that integral, then this is something that I've already done right here, and so I know exactly what it is. And that's going to be 1/4 e to the 4x plus c, and then last time to write it. So I get 3/16 here. Now, there is a different way we could do this problem, and we'll talk about it in a minute. But I'm going to show you the next example first, and then show you a little bit faster way to do this problem C and problem D. All right. So when we do D, all right, there's going to be two ways to work it. This is the harder way right here. All right. So if I think about what I have an algebra with the x squared and an exponential. So this is the same case that I had a second ago. If I go in the order LIATE, I'm going to let the u be the algebra. Okay. Alright, so making my box. U would be the algebra, and dv would be e to the 2x dx. Now, thinking about the integration that we did just a minute ago with that e to the 4x, you know, as long as it's an x to the first power as that exponent, you're just going to multiply by the reciprocal of that coefficient. And then u is as x squared, du is 2x. Alright, so then this is uv minus the integral of v du. So let's plug that in. So u v minus the integral of v du. I told you I'd forget my dx. Okay. Alright, so multiplying that, I get 1/2 x squared e to the 2x minus, alright, so when I'm multiplying the inside, that 1/2 times the 2, they're going to cancel, and I just get integral of x e to the 2x dx. Now, don't try to bring that x out front. You know, you can only bring a number out front, okay? Alright, so if I try to integrate this one, you know, and if I try to do u substitution, then du is just 2, and I have an x in the front. It's not a straight u substitution. What this is another integration by parts, okay? So, we're going to do another box. Now, the hard part in here is just keeping up with the negative signs and not making a silly mistake with those. So, we'll try to be super careful. Okay. So I got an algebra and another exponential. So again, LIATE, we know we're going to go with u being the x and dv being e to the 2x. So that's a 1 and that's a 1/2 e to the 2x. Alright? Okay, so now we're going to have 1/2 x squared e to the 2x minus. Okay, so this is going to be another uv minus the integral of v du. We're going to have to plug in those u and v's and du's with our new box, but we want to be careful of this negative sign out front. Okay, so we've got 1/2 x squared e to the 2x minus, alright, u v minus the integral of v du. Okay, so now as I simplify this next line, I'm going to distribute that negative. Okay, so again, I'm just copying this one down each time. Alright, so this gives me a negative 1/2 x e to the 2x right there. Okay, and then if I distribute that negative, then this is a positive. Okay, integral, let's pull the 1/2 on the outside, e to the 2x dx. Okay, so almost finished. Alright, I'm copying this down. I'll have to do it one more time after this. It's really important to be neat as you're doing this and not get lost in your problem. Alright, we've got to integrate this. Okay, so what I'm doing now is integrating this e to the 2x, and we've done it a whole bunch. We know it's 1/2 e to the 2x. Alright, so let me simplify that last piece, and we'll be done. And I call this the harder way to work this problem, and it's not that it was that difficult. It was just there's a lot of room for careless mistakes in this problem, and especially if you'd had some, like a negative exponent on that e, then it kind of gets you have to be super careful not to make a careless mistake. Okay, we have another way that we could work this problem, which is a little bit faster and a little bit easier in my opinion. So I gave you this note, and it says whenever you pick u, okay, and u is an algebra, whenever you LIA and you get u is that algebra, you can use the tabular method instead. We can use it whenever you are able to take derivatives of u down to 0. Okay, so we're going to look at that same problem. So look at all the work that we had on this problem. It took up that whole page for us to get it, and we'll see how a little bit faster here. Alright, so again, we've got the algebra and we've got the exponential. So whenever you realize, oh, wait a minute, okay, my u is algebra, you can do this tabular method. So you're going to make me two columns, a u column and a dv. So we're not going to do the box, alright, but we're going to pick u in the same way. U is x squared, and then whatever's left over is dv. Okay, you don't have to put the dx there. Okay. Alright, what you're going to do on this side is you're going to take derivatives down to you get 0. So like derivative of x squared is 2x, derivative of 2x is 2, and derivative of 2 is 0. You take derivatives until you get to 0. That's why we can use it when u is algebra, because if it's an algebraic function, when you take those derivatives, you're going to be able to get down there to 0. And then on this side, you're going to even out the columns, but as you go down, you're going to integrate, and you want to even it out. So you're going to integrate it and get, I need 3 lines of it. So if you integrate e to the 2x, it's just a 1/2 e to the 2x. Right? And then each time I'm multiplying by another 1/2, so I get a 1/4 e to the 2x. You can do all those u substitutions, but each time you're just multiplying by the reciprocal of that coefficient of the x, and then by another 1/2 would be 1/8 e to the 2x. You want to even them out, okay, where they stop at that same place. Okay. Alright, so you got your u column with derivatives all the way down, then you got your dv column that you integrate all the way down, and then this is what you're going to do. I'm going to switch colors. Alright, you're going to join, you're going to start here and you're going to join them up, and you're going to do a diagonal. That one to that one, that one to that one, that one to that one. So there's going to be nothing ever that goes with this one or this one, okay? And however many, lines, you would just keep going. Alright. And then you're going to alternate your signs. You always start with the plus. So on your lines down, you're going to always start with the plus. That one's a positive, that one's a negative, that one's a positive. Okay. So my answer, I'm going to put this together, is going to be the endpoints of the line multiplied with that sign. So let me show you what I mean. So I'm going to multiply. Oops. There we go. I'm going to multiply that, okay, and put it together with the positive sign. So I've got 1/2 x squared e to the 2x, okay, it times the positive. Okay, now we get a new color. Let's do orange. Then I'm going to multiply the next line. So that's that with a negative sign. So I get a negative, and if you multiply the endpoints, you got a 2x times a 1/4, so you get 2x over 4, or 1 over 2x e to the 2x. Okay, so all I did was multiply the endpoints. 2x times 1/4 e to the 2x. Okay, and I reduced it. And then I got one more to go. Let's do that one in pink. So it's going to be this one. So I need to do a 2 times a 1/8. So, and a positive sign, 2 times a 1/8 is a 1/4 e to the 2x. Plus C, and look at the difference. Exact same answer, okay, but look at the difference in the amount of work. That one was so quick, instead of having to do that by parts twice. Alright, let's try another one. Let's look at E, and we'll do this one a tabular method too, because when I look at my two functions, I got an algebraic function and a trig function. Okay, so LIATE, the A comes first, so U in this case would be x squared. So then dV is sine x. Okay? Alright, so when I look at this one, okay, you're going to take derivatives all the way down to 0. You get 2x to 0. Okay, and now you want to integrate sine. Okay, so integrate sine is negative cosine. Alright, to integrate negative cosine, you get negative sine. And to integrate negative sine is just cosine. Alright. So now join up those diagonals, here to here, here to here, here to here, and alternate the signs, starting with the plus. Plus, minus, plus. Okay? So let's multiply those endpoints. Alright, so I get an x squared times a negative cosine x with the positive sign, but you've got that negative cosine x, so it's going to stay negative. So negative x squared cosine x. And if you want to, you can put the positive in the front, and you say, alright, I'm multiplying an x squared and a negative cosine x. What do I get? If you need to write it all the way out, do. The next one would be the negative sign, but then you're multiplying a 2x and a negative sine x. So that's going to switch it to a positive 2x sine x. And then the last one, you got the positive line, and then you got the 2 times the cosine x. Okay. So much faster than doing the box. But again, it only works when you use algebra. One of the problems that you'll see a whole lot is something similar to this one. You're just going to integrate the natural log of x. And a lot of times people will stare at this one and not know what to do, and it won't immediately hit them that this is an integration by parts, because, you're looking at it, usually it's by parts when you've got the product of two functions, and you can't separate that natural log from that x. It's natural log of x. The only thing you have here is a log, okay? But you'll see this one, in various forms. It might be natural log 3x or whatever, but works the same each time. Alright, so you can't do the tabular method because you got that natural log in there, L-I-A-T-E. The logs are always going to be U first. Alright, so the only thing that you have left over is just dx. If it makes you feel better to write 1 dx, please write the 1. Okay? Alright, so derivative of natural log of x is 1 over x, and to integrate 1, we just get x. Alright, uv minus the integral of v du. So u v minus the integral of v du. Sorry, dx. Okay, so that's x times the natural log of x minus, what happens with that x times that 1 over x? So they cancel, so it's just the integral of 1 dx. So this is x natural log of x minus the integral of 1 dx is just x plus c. Alright, and then let's do this one. Integral of e to the x sine x. This is a special one that you'll see, and I'm hoping I can fit all the work here. I might have to come over to the side and do a little bit. Let's see. Alright, so last one, what do I have? I have an exponential and I have a trig. So, no algebra, no tabular method. Let's draw our box. Let me separate this. Okay. Alright, so u du, v dv. Alright, so if I go in the order, no L, no I, no A, but I do have trig, so there we go. So that means e to the x dx would be what's left over. Alright, so let's fill it in. If u is sine x, then the derivative of sine x is cosine x. And if I have to integrate e to the x, it's just e to the x. Alright, uv minus the integral of v du. Watch what happens on this one. So we would get sine x times e to the x minus the integral of e to the x times cosine x dx. Okay, so that's e to the x sine x minus integral of e to the x cosine x dx. There's no simplifying I can do right there. And then that throws me into another by parts. I've got an exponential and I've got a trig. So this is going to be the same type box. Okay, so I would do it again. So I'm going to make my box. Alright, so no L's, no I's, no A's, but do have a T. And that makes that here. Alright, so if u is cosine x, then du is negative sine x. Okay, and then that's just going to be e to the x. Sorry, dx right there. Okay, so if I kept on going, then I copy that e to the x sine x down. Minus, alright, so then that's going to be uv minus the integral of v du. And again, when you have to do these by parts twice, just be really careful with your signs. Okay, so that's e to the x sine x minus, alright, I'm going to go ahead and distribute it. That would be uv, so that's e to the x cosine x. Alright, and if I distribute, I get plus. Okay, be careful. So distributing it gets me a positive, but when I multiply it, that v du, then that's e to the x times that negative sine x. So what I'm going to do is pull that negative on the front. And I'm never going to get out of this loop. Okay, I'm going to get stuck. Okay, I would keep going and I would do another integration by parts, but if you notice this right here, this is exactly where we started, right? So then I would just get right back with this box, which would give me right back to this spot. I would never break this cycle. Okay, so when you have one of these where you're going to be stuck in a cycle, Okay, what you want to do is do me enough by parts boxes where you get to where you get the exact same problem that you started with. So we had to do 2 boxes before we got the expression that we started with. Okay, so now let me show you what we can do after that. All right, so I'm gonna write this whole line over, but I'm also gonna write the original problem in front of it. Okay, so let me cancel this. Let me add another page. All right, so let's see. Hold on, that didn't work. Alright, so I'm trying to switch it to white. And I've got something over here that I need to get rid of. Sorry y'all, we got that new software and I'm still... Can y'all see the red if I write? Yeah, okay, we'll be fine. I'll just do it right here. Okay, so we've got original problem, integral e to the x sine x dx. And let's see what we've got it equal to. So I'm going to go with picking it up. That's equal to this whole thing right here. So far I've found that that's equal to e to the x sine x minus e to the x cosine x minus integral of e to the x sine x dx. So you're going to write that out. You want to get to where you've gotten back to the same problem. Okay. Now what we're going to do is this. All right, you're going to add this to both sides. To get that off of that side. Cancel it out. Okay. So now we've got 2 of these integrals. And it equals e to the x sine x minus e to the x cosine x. Okay, and then remember we're just trying to solve for the integral of e to the x sine x. So now what we can do to get that by itself is we can divide both sides by 2 to cancel that off. And now we have an expression for that integral that doesn't involve any other integrals. So most people write it like this: 1/2 e to the x sine x minus 1/2. You're going to divide them both by 2. E to the x cosine x. Okay, and so you'll see that whenever you're I'm trying to put my plus C on there, I'm running out of room. You'll see that whenever you get stuck in one of those cycle problems. So again, you want to do enough to where you get the expression that you started with, what you're originally trying to find, and then you can treat it as an equation and move it over to the other side and solve for it like that. Alright, so make sure that you go try your